Yes.
Camera. Practice.
Okay, good.
Did it work? Is it working?
It's working.
Hallelujah! It's a miracle.
It's a miracle. I've learned what was going on. When I switch classrooms, I have to exit the program and then re-enter it again. I don't know why. I think it's because I'm switching to a different
Wi-Fi or
camera. I don't know. It might be the Wi-Fi too. That's possible. I hadn't
What if
thought
you
of
just bring the camera with you?
Then
Well,
they
Nate
can-
uses it.
Well, Nate uses it, so that's why we don't. But we probably, it's all set up. You know what I mean? So, anyways, so we don't have a lot of time, which is fine because this is actually really easy. Up to this point, you have learned how to graph equations, no problem, right? And we've actually done this once with whiteboards once. I had you guys do this. But first of all, let's just talk about. I'm not saying graphing an equation. I'm saying graphing a system of equations.
So what's a system?
What is a system? Anybody have ideas? Like what's a stereo system? Have you guys heard of that term? Maybe that's outdated too. I don't know.
Yeah.
Okay, so Dee Dee raised her hand. Guys, Dee Dee raised her hand. So it's a group of things that work together. You guys agree with that? A stereo system. It's not a stereo. It's a stereo and stereo speaker wires and speakers and a CD player and surround sound, other speakers, right? And maybe a CD so you can play something. Oh, and how about a tuner? So do you have those things nowadays?
No.
Yeah. What do they call them now?
You mean guitar tuner?
Well, no, like radio, like a radio.
Oh,
thing.
yeah.
You know, I don't know. Is that still called a tuner?
No, Gary.
I'm
Gary, we need to use
whatever,
a
I don't know.
dictionary of old
Okay.
stuff to new. Like Gary language to modern day.
Right, I know.
Gary modern day dictionary.
Oh God, I'm terrible with some of this stuff. I still to this day do not know how to deal with these TVs that have 5 remotes. And I go to Michael's house and he has 3 remotes for this big screen television. And for the life of me, I cannot get this thing to work because they all say on
There's
and
an
off.
on button
And they
on
all
the
have an
TV.
up and down arrow, and they all have a left and right thing, and a change channel, and a volume thing. How am I supposed to know which one I'm supposed to use?
There's some on the TV, like there's buttons on the TV.
There's an on button on the back of the TV. It's this little black square.
I never thought of that.
And then there's on the front.
Okay. Anyways, all right. So back to this. So, okay. So a system means more than one, right? It's a group of things, right? So you can have an equation, or you can have a system of equations, which is a group of equations, right?
Crazy talk.
And in this case, in Algebra 1, so Skylar, listen up. In Algebra 1, we're only going to be talking about, when we talk about systems of equations, we're going to only be talking about a group of 2. So 2 equations. When you go to Algebra 3, you're going to look at 3 equations and maybe more, 3 or 4 equations. But for now, we're only going to talk about 2 equations, and we're asking you to solve that system of equations. Now, when I say graph an equation, you just graph it, and it's a line that goes on forever and ever, right? If it's a straight line, right? But when I ask you to solve a system of equations, you graph them both on the same graph, right? Boom, and the other one might be boom, right? The question is, where's the solution? I've got 2 lines. Where would you just think there would be a solution? Yes? The colliding point. That's a cool word. I never heard of that. Say that.
Colliding point.
Yeah, that's great.
It sounds like
Colliding point,
explosions back
which is the intercept, right? It's where they intersect, right? It's where those 2 lines intersect, right? You get that? It's not the x-intercept or the y-intercept, x-intercept or the y-intercept. It's where they intersect, where they cross, that one point. Now, why would that be the solution? So, Skylar and Bella, listen. Why would this be the solution right there? Skylar.
It's like the point where the 2 intersect thingies.
It's where they 2 intersect, but that point is the only point only point in the universe where the x and the y actually work together for either equation. Does that make sense?
Yeah.
Right? So, for example, we're going to do a problem. Let's just
What about
parallel.
In the
Yeah, I won't give. If
Do
I give,
you ever get parallel? Like,
you do, and then there is no solution, right? Because think about it. If you have two parallel lines, they never cross, right? So there's no solution. Because you're looking for a point that is true for both equations, all right? So I'm going to give you two equations here. X.
What if you have 3 lines?
Actually, let me just redo this. So we're going to say this y is equal to negative 1/2 x
Well, not next year.
plus 3. And then we'll make this one y is equal to x minus 3. Okay, I have two equations here. You guys agree with me? Two equations. I hope I did that right. So here's my graph. This is the cool part. It's so easy to do. Now, when you're doing this, though, I'm gonna warn you. It's really easy to do if you are really accurate. And if you are not accurate in your graphing, if you're just casual and say, oh, it's approximately 2 is approximately here, and 3 is approximately there, and whatever, you're not going to find an answer, right? So you got to be precise. So here we go. We've got, they're both in what format? Y equals mx plus b, which is slope, intercept. As my slope and my intercept. Slope, intercept, right? So immediately I go up 3. 1, 2, 3. All right? And I go from, so I put a dot there. I'm doing this first one. And then I go down 1 and over 2. Let me just draw my thing. Down 1 and over 2, put a dot. All right? And then I'm going to go down 1 and over 2 again. It's a really good idea to keep going with your slope. Down 1 and over 2. Looks like it's more over here. Down 1 and over 2. It's like there. And then down 1 and over 2. Boom, boom. So I'm putting a few dots. It really helps you to draw a really straight line. Because if I just had 2 dots like this, right? I could draw it like this, or I could draw it like this, or I could draw it, you know what I'm saying? And so let's say they crossed out here. Look where I could have, I don't know which is my right answer. You see what I'm saying? But if I have several dots, it's really hard to draw the wrong line, right? You see what I mean? Right? So to do several dots with my slope. Now my next one, I'll use a different color just so that maybe I won't. Yes, I will.
It's still possible to draw a non-straight line.
All right, so here, I didn't draw my line though, did I? So here we go. All right, now technically, if I used a ruler, that would be a very good idea here, but I didn't. All right? Oops. All right, so now this one. What's my slope? 1 over 1, right?
Yeah.
Rise 1, run 1. So I go to negative 3, 1, 2, 3. I'm trying to be really careful to make all my points exactly the same distance. So negative 3, put a dot, and I go rise 1 and I run 1. I rise 1, run 1, boom. I rise 1, run 1, boom. I rise 1, run 1, boom. I rise 1, run 1, look at that. And then I rise 1, run 1, boom, right? So if I draw my line now, I can tell that this is the point that is the only point that intersects those 2 lines. Do you agree? I mean, that is on those 2 lines.
Like curve around.
No, we got 2 minutes, guys. 2 minutes.
It's in 2 whole
Jake,
minutes.
do not ring it. I've got 2 minutes.
Of course it's Jacob.
According to my watch, according to that clock.
2 whole minutes. That's
Right.
like bunch of. That's like 100.
All right, so guys, listen.
According to my home.
So what is this point? What is
No,
this
you have
point?
4 minutes.
It's over 1, 2, 3, 1, 2, 3, 4, up 1. So you guys all agree with me that's 4 comma 1?
Yes.
All right, that's the point I want. That would be my answer, that 4 comma 1 is my answer. And now technically, you're supposed to also prove that that's true. So we come back here. I'm not asking you to do this on the homework tonight, but if you want to do it, that's great. but this is what you usually do. You take that and point. That's your answer. So I would say the solution is 4 comma 1.
Can we just
But-
solution equals 4 comma 1?
Yeah. Or, but not or. But what I would do now is I would say, if I erase this and put a 4 here, right? And erase this and put a 1,
Wait, why'd you put 4 over 1?
because this is my x,
Why didn't you just put
this is
1?
my 1. All right, so
Why
I'll
didn't
just
you
put a
just
4.
put 4?
I'll just put a 4. That's fine. Right? So is this a true statement? So
Yeah.
what's 4 divided, half of 4 is 2, right? 2
But it's a
plus,
negative 2.
oh right, negative 2, thank you. I was going to say, what's going on? Negative 2 plus 3 is 1. 1 is equal to 1. Let's try this one. If this now becomes 4, 1 times 4, and this is 1, 4 minus 3 is 1. 1 equals 1. They both check.
Carry your
Right? It's the only point in the universe where these two lines intersect. That's the point you're looking for.
This video is like 5
Okay.
minutes long.
All right, so here's the homework.
It'll make it
That is like
crazy value.
Make sure you guys get the homework.
that is like in the video share. I think there's that. I'm getting it.
May have you have the homework?
Here, Nate, I mean, Gary, I'll give you
Oh, sure, I didn't.
I'll just do my homework. My homework.
Gary, can I see what we're doing? Can we see? Because you want to give it that, because you want us to have easier
I think that's right. Oh, God. I guess, is that clock wrong? That's what I'm going by.
No, it just restarted like 15 minutes ago.
It says hang on.
And deleted it. I made it